So far, I've dealt with normal areas, stub areas, and totally stubby areas in OSPF. Now's the time to tackle not so stubby area. Not so stubby area, or NSSA, is the one that filters out LSA type 5, just like stub area. But it allows introduction of external prefixes or allows the presence of ASBR in that area. But since LSA type 5 are not allowed, they will be introduced as external prefixes type 7, LSA type 7. And once they are introduced as LSA type 7, so we're not violating the rules, LSA type 5 are not allowed in the area, but LSA type 7 will represent the external networks or subnets. Once they reach the ABR, the advertisements into the backbone area will convert those LSA type 7 into LSA type 5. There's one caveat though. If I make, let's say, area 2 NSSA and introduce external prefixes, maybe on switch 1 shortly, the routers within the area by default, they are not getting the default route. So if, for example, there's a 1030 some subnets introduced from EIGRP into OSPF, R1 can reach them, but by default, it won't be introducing itself as the gateway of last resort for LSA type 5, which are now forbidden in that area. And as a result, the R3 and switch 1 won't be able to reach those networks. So to make that happen, I will need to introduce for NSSA area 2 additional keyword on ABR, which is default hyphen information hyphen originate. So as of this moment, the area 2 is just a regular normal area, and the show IP route on R3 OSPF, we are receiving everything, inter area, external as well. Now what I'm going to do quickly is enable on R1 and R3 the area 2 enable as NSSA, not so stubby area. So what I'm going to do first on R3 real quick, router OSPF 1 area 2 will be not so stubby area, and I'll need to do the same thing on R1. Obviously I'm going to lose the neighbor shortly, area 2 NSSA. Once they agree on the same flag, which is NSSA now, the adjacency was rebuilt, and what we have now available in terms of routing, something is gone. Do show IP route OSPF. What is gone is the external type 1 prefixes introduced on R6. So I cannot reach those networks. Do ping 10.30.0.15. One of them is this. But R1 is connected to area 0 and can still reach them, has them in the routing table. So do ping 10.30.0.15. It can be the gateway, but by default, it does not introduce itself as the gateway of last resort. For that to work on ABR, I need to introduce the NSSA area with this additional keyword, default information originate. When I do that, what happens, R3 is now receiving the gateway of last resort, but as a LSA type 7. So if I go show IP route OSPF here, I'm receiving N type 2. The metric does not get incremented like E type 2. It's an external prefix, LSA type 7, advertised by router 1, and router 1 presents itself as the gateway of last resort. So do show IP OSPF database, NSSA advertised, router is 1111, we are receiving a default route, all zeros with a mask, all zeros, and R1 is our gateway. So now we can reach those external prefixes not knowing them specifically in the routing table, and it's reachable right now. What I'm going to do as a second thing is, so the purpose of that is that I'm going to have a switch 1 which will connect to external networks, and I will be able to introduce them into OSPF area not so stubby as LSA type 7. LSA type 5 external are not allowed, but LSA type 7 are allowed, and they will be converted into LSA type 5 on ABR, which is R1, while introducing them into the rest of the system. So let's now enable routing on the switch 1. So let me jump to switch 1 real quick and make it also NSSA. Switch 1 right here. So conft, by the way, do sib. So these are the networks subnets I'm going to introduce into OSPF as external NSSA type 7. They have all things in common is 10.1.7. So everywhere 10.1.7. Okay, so let's go. First of all, let's enable just a regular routing. Router OSPF 1. IP routing not enabled. Switches by default have routing disabled, so I have to do IP routing command first, and then it will let me to do routing OSPF. Network 10.1.2.100. So this interface will be running towards R3 in area 2, and area 2 is NSSA. Otherwise, the flags wouldn't match between us, and we would never become adjacent routers in OSPF. So that is the basics of OSPF. So do show IP OSPF neighbor. Shortly we will be fully adjacent. Now, meanwhile, I'm going to create an IP access list standard, and I will name it connected. So this is a named access control list. I will permit anything 10.1.7.0. So that matches all those, meanwhile adjacency was built. That matches all the interfaces that will be introduced into OSPF as external LSA type 7. Now to do that, I need a route map. So in a global config mode, I will say route map connected to OSPF permit 10. And what am I going to permit? Match IP address, and I call the access control list connected. So quick test, do show run maybe first section connected to OSPF. That's what it looks like in the configuration. So if something is true in the access list called connected, which is anything 10.1.7. anything, it'll be permitted. I can also look at that to show route map this way. So same thing. And what am I going to be permitting here? Well, if I go to router OSPF 1, if I say redistribute connected networks, subnets, but I will have a route map that matches on those particular 4 prefixes, connected networks. It's called connected to OSPF. If that's the case, now I have introduced external networks into the area that filters LSA type 5. So show IP OSPF database. They will be signified as LSA type 7, and they will show up on the router 1 here. Do show IP route OSPF, same on R3. As LSA type 7. However, if I look at this, I forgot to do a switch ID. What's my ID? Show IP OSPF include ID. I'm 10.1.17. I'll change it to router OSPF router ID, so it's maybe easily noticeable. Now, I need to clear IP OSPF process, unfortunately, to make that happen. So now I'm 7777. So if I look at the show IP OSPF database here one more time, show IP OSPF database, I will see LSA type 7 shortly, right there. So I have LSA type 7 advertised by this router. So let's just look at this show IP OSPF database, and let's go for NSSA external, and advertised router will be 7777. So what is going to happen here, for every prefix advertised by switch 1, the router 1, while sending them into area 0, the backbone area, from type 7, convert them into type 5. It's going to be a translator to do that. By the way, if there were two routers doing the translation, the one with the highest router ID wins and becomes a translator. So if I jump to R2 now and I look at those prefixes, so let's say 10, anything 1017, if I go to R2, it doesn't see them as an LSA type 7. Show IP routes include anything 1017. Translation occurs on the router 1, and what was LSA type 7 in area 2 becomes LSA type 5.